Here we have another question from the combination of solids. Here we're going to combine a cube and a hemisphere, right? Let me read the question to clarify more, to understand more. A cubical block of size 7 centimeter. A cube of size 7 centimeter. It means length is 7, breadth is 7, and height is 7 of that cube is surmounted by a hemisphere. So over that cube we have a hemisphere. What is the greatest diameter the hemisphere can have? So what is the maximum diameter that a hemisphere can have if we are going to surmount it over a cube of having side 7 centimeter? So find the surface area of the solid, and after that the combination of both, the solid means representing the cube as well as the hemisphere together, what is the total surface area we need to find out. Okay, the question is saying something like this. We have a cube, so let me make a cube something like this. All right, let's say this is my cube. So here I have a cube, and the question is saying us that we are going to put a hemisphere over it. All right, so hemisphere can be smaller like this, or can be even bigger than this, like this. So while making the hemisphere, what we need to find out, what we need to do actually, we need to make such a hemisphere that have the greatest diameter. When I make a smaller one, that diameter was very small, and when I made a little bigger, the diameter was more bigger. When I make this much bigger, the diameter was more bigger. So what is the most biggest hemisphere having the greatest diameter? So greatest diameter can have, can be the same like the edge of this, the side of this cube. All right, this is the side of the cube. All right, so let's make the hemisphere whose diameter is equivalent to the side of the cube. All right, so now here we have a hemisphere whose diameter is equivalent to the side of the cube. So that's the greatest diameter possible for that hemisphere. All right, and next thing, what we are given, that the side of this cuboid is given to be 7 centimeter. This is 7 centimeter, so definitely the breadth will be also 7 centimeter and height will be also 7 centimeter. All right, so as from the figure you can easily see that the possible total maximum, the greatest diameter possible, is also 7 centimeter. So now we can easily write the radius. So radius will be half of the diameter, 7 over 2 centimeter. So this will be also 7 over 2 centimeter, right? 7 by 2 centimeter. This will be also 7 by 2 centimeter. So now we understand the question as well as we picturize it also. All right, and one thing is left. This is hemisphere, so hemisphere will be something like this, something like this. Yeah. Now we have to give the answer according to the question, according to the demand of the question. And the question is demanding, find the total surface area of the solid. So we need to write the total surface area of the solid. And how do we do that? So we know everything now. We can find out easily the total surface area of this cuboid. All right. So now we can easily find out the total surface area of this cube, and then curved surface area of this hemisphere. And from those all, we have to subtract this little guy, this circle, because that's not visible. The visible is this hemisphere and this cube. This part is invisible. This is hidden, This is, you can say, the base in which this is the base of the hemisphere in which it is sitting, It is standing on this base. So we need to subtract this standing base. Keep in mind that. All right. So our total surface area of the solid will be equals to the total surface area of the cube, plus curved surface area of this hemisphere minus the bottom circle that is hidden, So finally, now we can say that the total surface area of the cube, that's 6a square. A means here the side of the cube, plus curved surface area of hemisphere, that is 2 pi r square, and the bottom of the circle. And see, this is a circle with the radius of 7 over 2 centimeter. So it is pi r square again. All right, and it's 6 times a square. A is the is here 7 centimeter, the side of the cube, that is 7 square plus 2 pi r square minus pi r square. So it's simply pi r square. All right, pi r square. Why don't I write the value directly? Pi, that is 22 over 7, and r, that is 7 by 2. All right, 7 by 2 whole square. Okay, its square. So it's 6 times 49 plus 22 by 7 times 7 over 2 times 7 over 2. Now we can cancel something. 2 times 11, this 7 and this 7 will cancel up, and 11 times 7, that is 77 divided by 2, and here we're 7 times 9, 54, carry over 5, and 6 times 4, 24, plus 5, 29, 294, and 77 by 2. So let me do by the calculator, that will be more faster. I don't want to make you wait. 77 by 2, that's 38.5 plus 294, that's 332.5, 332.5 centimeter square. So 332.5 centimeters square is the area of this solid, that is combination of hemisphere and a cubical block. I hope you understand this question, and if there is any more confusion to ask me, then please feel free to comment below this video, and please don't forget to subscribe the channel and hit the like button. Bye bye.